Hello, we are a group of Iowa State University students in Industrial and Manufacturing Systems Engineering. This semester, we have taken on a senior capstone project with King's Material. First up, let's meet the team.
Hi, I'm Harrington.
Hi, I'm Luke Vathing.
Hi, I'm Pulido.
King's Material is located in Eldridge, Iowa, and is a manufacturer of concrete, masonry, and landscaping products. Through initial meetings with King's Material, we have determined problems with the facility being inefficient truck dwell time, congested traffic flow, inefficient yard layout, and outdated technology. The objectives of this project were then determined to be to reduce the truck dwell times by a minimum of 10%, reduce inventory levels by 15%, reduce travel distance for forklift operators by 10%, and free up 3,306 square feet of concrete space to create a staging area.
The current state analysis was done on the truck loading area and yard layout. An AutoCAD model was used to map the current state of this facility. In the current state, there was no designated entrance and exit for customer vehicles and semi-trucks to enter and exit the facility.
The current state of the yard was analyzed using an ABC analysis. Additionally, it was determined that products did not have designated locations within the yard.
There was a time study conducted for the CSA to track the main activities that take place during loading vehicles. The most time-consuming activities were unbanding, banding, and waiting. The average semi-truck dwell time was found to be 46 minutes, along with the average customer vehicle time being 18 minutes. This created an average time for all vehicles being 29 minutes.
During the current state analysis, a work sampling study was also done to understand the work activities being completed by a forklift operator throughout the day. After the study, it was found that 26.34% of the observed time was spent doing non-value-added work activities. It was deemed that this could be a huge area of improvement for King's Material.
In the future design, an AutoCAD model was utilized again. In this model, a designated entrance and exit was implemented, the north being a truck entrance only and the east entrance being customer cars only. This segmented the traffic into semi-trucks and customer vehicles, allowing a smooth one-way flow of traffic. You can see there that there is also now an unbanding and banding zone that allows these processes to be done in parallel with the loading process.
For the future state of the yard, an analysis was done to determine products that hold the highest value. We did this by determining individual sales and yearly demand for each product. It was determined that over 20% of the products over the last 3 years have made up 80% of the sales. Using this, we split the products and the yard into an A, B, and C category, with an A section having room for up to 11,325 pallets.
The last idea for the future state design was to introduce tablets to the forklifts. These would allow for the forklift operators to be able to view orders so they could limit their time inside the office. We were also then looking to introduce forklift monitoring software so King's Material had a better idea and understanding of what work activities they were completing on a day-to-day basis. This all allows for a decrease in non-value-added work.
The economic impact of creating the future state design of the loading area would be a cost of $598 to implement the paint and signage. The savings that this will provide King's Material is $355,000 per year on the BTI trucking expense alone. This savings can be calculated from the decrease of semi-truck dwell time by 35%. It's estimated that it will take the current time of 46 minutes down to 30 minutes.
The cost of implementing the tablets would be $1,000, and the cost of implementing the software would be $5,000 a year. This could create up to 75% savings in non-value-added time, which creates savings of $12,800 per year saved in the non-value-added work activities.